Okay, we'll get started again. Okay. So for the rest of the class, we'll go into the lecture material a bit. I'll show you the first methodology that you can use. It's maybe not the greatest one, but it's something. Okay, so what's the goal of this course? What's a course about security evaluation methodologies about? So the idea is that you graduate, you have a degree in security now, you get a job, hopefully, and on day one of the job, someone's going to hand you something and say, okay, you're the security expert, can you tell me whether this is secure or not? Okay, and so what I'm trying to do in this course is give you some ideas about how to get started. What does that mean? How do you start answering that question? That type of thing. Okay. Now, the challenge with this is the thing that you're handed could be lots and lots of different things. Okay. And the way that you tell whether it's secure or not probably is going to be different depending on what you're handed. Okay. So, for example, if you're handed software, first off, software itself is very different, right? Like the difference between an operating system and a driver could be like very, very different in terms of what programming languages are used, how do you go about analyzing them, do you have source code or not, all those types of things. And then let's say I hand you like a circuit and I say, okay, there's a cryptographic key, it's on this circuit, can you make sure that no one can get the key out? Okay. Do you think that the way that you figure out whether there's a bug in the software and whether you figure out whether someone can probe the hardware to extract the secret key, do you think those are the same method? They're not going to be the same method, right? So the fact that there's so many different things that we have to consider the security of, it's going to be challenging for us to think about how you're going to evaluate all of these different things. And the short answer is there is no one methodology that's going to work great for everything, okay? But anyways, we'll get there. Okay, so you might be handed software, you might be handed hardware. What are some other things that, on day one, someone might ask you about the security of that's not hardware or software? Is there anything else? You cheated because you watched the lectures.
Yeah.
No, go ahead.
Networks, for example, or human protocols, data.
Okay. Okay, so Wi-Fi networks, so that would be a kind of thing. Networks aren't really software, they're not really hardware, they're more data, right? It's more the protocol level. When you have data, you also have things like cryptography. So you might be asked to look at an encryption algorithm, or it might not be a cryptographic algorithm, it could be an algorithm about anything, right? A machine learning algorithm or something like that. And so what are the security possibilities with it? People was mentioned, okay? So it doesn't have to be technical things, right? In fact, one of the most effective attacks is you want access maybe to a server room, you just show up at the company dressed like an IT worker and you say, where's the server room? I heard you're having problems or whatever, right? And so we'll go through, that's called social engineering. We'll have a couple lectures on that type of thing. But in that case, I'm attacking the human who's working there, as opposed to attacking the software or attacking the hardware. I'm trying to trick someone. Okay, what are some other things?
Future security.
So, sorry, say it again.
I don't know if it's right or wrong, but it's like for future, for the human, future security. I don't know.
Okay, so like future as in like
money or this. I don't know if it's included in the security.
No, everything's included. Yeah.
Like
The biometrics is
like money security.
Okay, yeah. So anything related to finance that might fall under
Yeah.
data, that type of thing for sure.
the biometrics and everything.
Okay, authentication. So again, that's more of a protocol kind of thing. Same, yeah. So biometrics, authentication.
Control mechanisms can be there.
Okay, so access control is slightly different. So you could attack access control because you're attacking the system that implements the access control. So then it's a software attack or it's a hardware attack, right? But sometimes maybe there's a flaw in the access control policy. Like obviously the company doesn't want students to be able to change their grade, okay? And so if you can log into different systems, Moodle, for example, and there is a grade book on Moodle, but you're not permissioned to do that, right? So what's stopping you from doing it? Well, there's this access control policy, okay? But what if you find some weird thing like, well, if I become a TA in this course, then it will think I'm a TA in this other course, and then I'll be able to change the grade in the other course. Like, I don't know, there might be some like weird path through all the policies where it allows you to change your grade even though you're not supposed to.
Role-based access is too.
Yeah, so there's rules and you're able to evade the rules somehow, okay? So first off, let's put a name on this attack because we'll come back to it. We call that escalation of privilege. I was privileged as a student and I have now professor privileges, or I have dean of engineering privileges or whatever, okay? And secondly, that whole category is what we call policies, okay? And so we'll also do some lectures later on policies, and we'll look at different examples of policies and the kind of loopholes that exist in policies. Okay, I think we did pretty good. Let's see. Okay, so networks, we talked about protocols, we talked about data, we talked about physical is another thing that we missed. So security also means security cameras. It means locks. It means, you know, this door has a lock on it. All those types of things. Organizational is more the policies, the procedures, laws, that kind of thing. And then humans. And this isn't meant to be like a comprehensive list of everything there is in security. Okay, this is just mainly trying to illustrate to you that like security is very, very broad. There's lots of different things. Okay, now let's think about what does security mean and how do I know whether it's secure or not? So we'll put the name evaluation on that. Evaluation is just trying to figure out whether something's secure or not, okay? If you go back to this list and you think, you know, I run a company and I want to make sure that you know, if IT people are coming in, they actually work for the company that they work for, and I don't want my employees to get tricked. So I'm going to put in some policies like they have to check the ID or whatever the policies are, okay? Now I want to know, is that enough? Is there some way around those policies? Like, am I still vulnerable to social engineering or not? So I need to figure that out somehow. I don't know how I'm going to do it. I'm going to figure it out. That's evaluation, okay? The process of figuring it out, okay? Now, whatever method I use, whatever recipe I use for figuring that out for social engineering, is that going to work for a computer chip? Probably not, right? Is it going to work for software? Probably not as well, right? In software, maybe I use static analysis. In hardware, I might be like probing things or, you know, trying to like physically remove things. Physical locks would look different, okay? So all of these different things are going to have different ways of, first off, security means a different thing, and then how you evaluate security would use a different methodology, okay? So I want to lower your expectations for this course. I can't possibly teach you a methodology that you can use on day one that will work for all of these things. It just basically doesn't exist. Or if it does exist, actually the one we'll talk about today is the closest to existing. It's just actually not that useful. It basically just kind of glosses the surface and it doesn't give you a lot of detail that you need, okay? But what we will do is we'll work through a couple of these across the course. So we'll spend a lot of time on protocols, we'll spend a lot of time on policies, we'll spend a lot of time on social engineering. The other things like software and hardware, you'll see a lot more in your other courses. And so, yeah. Okay, the other thing, or another thing that makes evaluation hard is you can't expect to analyze the security of something if you don't actually know what that thing is already. So, for example, if I say, like, here's a cryptographic protocol, I want to know whether it's secure or not, right? You're not going to be able to even start thinking about security until you understand cryptography and you understand the math that's involved and like what it's actually doing and why it's doing what it's doing and all of those types of things, okay? So you can't be a security expert if you're not already a domain expert on whatever it is that you're analyzing, okay? So usually that's how knowledge works. You learn a lot about the thing that you're studying, and then security is kind of like your secondary thought. Then you can start thinking about the security of it. And so there's this old saying about like, people who like try and find counterfeit bills, they don't spend a lot of time studying counterfeit bills. They spend a lot of time studying the real bill. So they know what a real dollar bill looks like. They know it inside out. They know all the holograms and all the features and the fonts and all that type of stuff. And because they've studied them and they know them so well, if you put a fake one in front of them, then they know it's off somehow. And then they can spend some time like trying to figure out what exactly is off about it. Okay, another thing that makes security challenging is you can never really say that something is secure. Okay? Security is more of what we call a negative concept than a positive concept. So usually the way that it goes, like let's say take cryptography, I would say there's 10 attacks that I know about. So what I can tell you is I tried attack 1 and it didn't work, or maybe it worked, but then I changed the algorithm, now it doesn't work anymore. I tried attack 2, I tried attack 10, none of them work, okay? So that's my definition of security. Does that mean it's actually secure? Not necessarily. What if somebody comes out with attack 11? I haven't even thought about it. I couldn't have looked at it because it doesn't even exist yet. But a year from now, someone's going to think of attack 11, and all of a sudden my system is not secure against attack 11. Okay? So as a security person, you never know, you're never done, right? All you can say is, based on everything that everyone knows, right, this is secure. But it doesn't mean that tomorrow someone won't come out with something new that no one's thought of before, and all of a sudden it's not secure. Okay, so methodologies also usually aren't complete. They're more like, here's a sort of laundry list of a bunch of things that do or do not work. Okay, so there's no really good universal evaluation methodology that's going to work for as well for a human as for a computer, as for software or whatever, okay? Either methodologies are going to fall into one of two camps. Either they will actually try to be general enough, and they do work and they are useful, but it's more for like brainstorming and they won't give you a lot of detail. The other type of methodology would be very detailed. It would be a very detailed way of understanding X, but X is very, very narrow, okay? And so that's what you're going to choose between the two. And through the course, we'll see both. We'll see different flavors of both. And we'll see some where like the level of detail that you go to is also adjustable. You can kind of choose the level of detail that you want to go through. So for today, we'll do one that's at the high end of the spectrum, okay? Not the most useful thing. It's not going to let you find attacks that you didn't know existed before, probably. But it is general enough to work on everything. So in general, these high-level methodologies, like the pro is that they're applicable to all sorts of different things. The con is they don't go deep. Usually it's a starting point. You're just sort of brainstorming about what security is. It gives you somewhere to start. Okay, it's not going to be the end product, but it gives you somewhere to start. Another thing too is sometimes you have to present your findings to other people. It can also give you a way of organizing your findings. So you can say, okay, there's a bunch of security considerations. Let's go through them. Let's consider the ones in this category, and then we'll consider the ones in this category and things like that. So it's also useful in that from that perspective. So 3 examples of high-level methodologies we'll go through in class. So today we'll talk about something called STRIDE. Next class, we'll talk about evaluation frameworks. And then we're going to do a bit of a detour of one of the aspects of evaluation framework, which is usability. And then we'll come back and we'll do attack trees. At least that's in the current layout of the course. Okay, so today we'll talk about this. These 2 things you won't know about until you see them. Okay, so STRIDE is really, really simple. How many of you have heard of, like, you've taken a security course already at Concordia and someone told you about CIA, confidentiality, integrity, availability? Yeah, so I see some heads nodding. So this is basically like, it's a very common mnemonic, which is just a fancy way of saying like 3 letters and you can memorize them. But it basically tries to argue, well, most security falls into these 3 camps. Okay, there's security about confidentiality, which is keeping secrets secret. You have security about integrity, which is that things shouldn't change without you knowing about it or without you being able to detect it. And availability just says that things are available when you need them. They're live, they're online, you can access them when you need them, okay? Now the problem with CIA is people said, well, what about authentication? Authentication is like an important security topic, right? Like biometrics and all that stuff. What is it? Is it a C thing? Is it an I thing? Is it an A thing? And like it's not really a C thing. It's not really an A thing. Maybe it's an I thing, but it integrity, I think of like preventing malware and things like that. I don't really think about. So it's sort of its own thing, right? And so then people said, okay, well, that's no problem. Well, let's add authentication. So now it's like CIAA. And then what about authorization? We talked about that access control, right? Well, maybe that's its own thing. It's not, doesn't quite fit on the other ones, right? And so anyway, people kept sort of adding to it. And so what Stride is it's basically just CIA plus 3 additional properties that they felt. So it comes from someone at Microsoft Research, Adam Shoshak. So he felt like, CIA doesn't capture enough. And so here's a 6 categories that does pretty well. And Microsoft uses it internally, and it seems to be like pretty comprehensive. Okay, so Stride, STRIDE, just like CIA, it stands for certain things, okay? And the thing that's a little confusing with CIA is they flip around the property. So, for example, the C in CIA is confidentiality. And what Stride does is it tells you the attack as opposed to the security property that you want. So I want confidentiality. So I'm trying to prevent something else. I'm trying to prevent information disclosure, okay? So Stride is just, it's flipped around, so it's worded in terms of the attack as opposed to the property. But other than that, CIA is there, and then you have 3 other new properties, okay? So spoofing, S, violates authentication, and it basically means you pretend to be something that you're not, okay? Tampering violates integrity. It means that you make modifications to something, and either you shouldn't be allowed to or they're not detected. Repudiation's a little weird. I'll circle back to that one a little bit later, but it basically is like you say that you didn't do something that you actually did, more or less. Information disclosure is about providing confidentiality, keeping secrets secret. Denial of service violates availability, which just says that things aren't online, you take them offline, that type of thing. And then elevation or escalation of privilege is what we talked about, where like somehow you figure out as a student on Moodle to make yourself a professor because you want to change your grade. Okay, so that was an elevation of privilege. Okay, and most attacks can pretty cleanly fit into one of these 6 categories. Sometimes attacks will do multiple of them. Like you'll do spoofing to get in the door, and then you'll do a tampering attack, and then you'll do, ultimately you want an escalation of privilege. So sometimes attacks are not, they don't cleanly fit in one category because there's multiple stages to the attack, okay? But if you look at a stage of an attack, you should be able to attribute it to one of these 6 things, okay? And there's not a lot, like they are like 6 actually different things, and there's not a lot of things that you'll find out there that aren't one of these 6 things, okay? So they're comprehensive, and they also distinguish themselves. Okay, so I have a couple slides just about each one. Okay, so spoofing is basically lying about who you are. Okay, now who you are might be a computer, it might be a process, it might be a file, file name, that type of thing. It might be an address. So I call you up and I change the caller ID so it looks like, the prime minister's calling you or something like that. So that's spoofing. Another thing that shows up a lot in spoofing is sometimes names sort of expire. So you might be able to go and register that domain after it expired, and then all of a sudden, like say it's a software project and it expires, you get the domain, then you put up malicious software, but there's still a bunch of people who are still linking to that domain or whatever, and so now they're getting your malicious software, okay? Any kind of redirect where you're like, go here, go here, go here, there's also vulnerabilities. It makes it, like you have to really lock down against spoofing attacks. It makes it like trickier. Another kind of vulnerability we see a lot these days is time of check versus time of use. So that's a big, long acronym. But the way I'll describe it to you is as follows. Let's say that you and your friends go to a bar in Quebec, and some of your friends are under 18, I guess, here, and you want to get them in, okay? They're not allowed to get in. And so you have a great idea. This is my great idea. I'm over 18, so I'm going to go, and someone's going to ask me for my ID, so I'm going to show them my ID, okay? So what is the person, the security guard or bouncer or whatever, what do they do when they look at my ID? So they look at the ID. Does it look valid? Yeah, it's a Quebec driver's license. It looks valid. Then they'll look at my age. Am I over 18? Yes, no. Okay. Then they're going to look at my face on the ID. They're going to look at my face in real life, and they're going to say, is this the same person? Okay. So my face matches the face on the card. Card says I'm over 18. Therefore, me, the human, is over 18. I can go in to the club. Okay. Now, here's my great idea. Okay, I have my 17-year-old friend with me, and what I do is, that sounds really sketchy, but anyways, it's my son. I want to bring him for whatever reason. Okay, so what I do is I show them my ID, and they do all the checks. Okay, they check my age, they check the face, and then right when they're going to give me the card back, what I do is I tell my son, really quickly stand where I was standing, because they already checked my ID, and they said you're allowed to go in. And then they'll give the card back to my son instead, and he'll go into the club. Okay? Now, does that work in real life?
No.
Why not?
Face is different.
Okay, well, you already did the face check, though.
Depends how sober the bouncer is also.
Yeah, sure. Probably not fast enough, right? Okay, so they may notice that the face is different, but just if you think of it like a machine, right? They did the face check. They're satisfied, so they give it back. The main thing is I can't get my son to stand where I was standing quick enough without someone noticing. Okay? Now let's say it's a computer. Okay? There's a process, a file or something like that. I do all the software checks on it. Okay? Could a computer, right when I'm done the check, but I'm about to give it the authorization, okay? Could that thing that I'm about to authorize, let's say it's a process, could it get swapped out with another process faster than I could authorize it? Of course, okay? Computers get interrupted, they get suspended, there's multiple things going on, there's multiple cores and threads and all of that type of stuff, okay? So nothing happens, sequentially in a computer, okay? So yeah, absolutely, it could do all its checks, it could be about to give me the authorization, it gets suspended, and during that time that it's suspended, you completely change the process, and then you resume, and then you end up handing off the credentials to the wrong thing, okay? So that's time of check versus time of use, okay? And so it's really important. And how do you combat it? Use things like locks, right? So you sort of lock it, and then you do all your checks, and then you don't unlock it. Like basically you lock it so it can't be swapped out until you've given the authorization. Then when you're done giving the authorization, then you unlock. Social engineering, that's another big aspect of spoofing. Tampering is just modifying things. So it could be code. That's the most obvious. Like malware is basically just tampering with code. It could be code that's stored on a repository. So when people download it, they run the malware. It could be code that's already running or it's already installed on your computer, that type of thing. Similarly with data, it could be either transmitted, like it's going across the wire and you're making modifications to it, or you find where it's stored, you make the modifications to it at that time. It could be physical objects, like if you pick a lock, that would be considered a tampering attack. You could poison data sources as well. So it's sort of like modifying data, but you have a specific objective in mind. So like with all the machine learning that you're hearing about or learning about, that there's training sets that are used for it. And so there's different attacks where you could poison the training set so that it trains wrong. Or there's very easy ways to defeat the training. Say it's facial recognition or something like that. You could poison it so that you could very easily trick it later when you wanted to. Okay, again, these are absolutely not meant to be comprehensive. So I'm just giving you some random examples of each of them. But there's we could do a whole lecture on every type of spoofing and every type of tampering, just to give you the flavor of what the differences are between them. Okay, repudiation is basically if you did something and then later you say I didn't do it, We call that repudiation, okay? If you can't deny doing something, we say non-repudiation. So like, for example, if there's a really good log system that logs every single action, it's tamper-proof, no one can change it, then that provides good non-repudiation. Then people do things and you can't undo them, okay? But if you're like, oh, I ordered something from Amazon, and you know, and then I get it, right? So I have it, it's a new TV, I'm watching the TV, but then I just go on the Amazon app and say, oh, it never came, right? Now, how do they combat that? Well, they combat it, with logs, because they'll take a picture of it sitting on your porch, okay? So that's the sort of the non-repudiation, okay? But even still, you might say, maybe they forgot to take a picture, right? And you're like, okay, yes, now's my chance, right? So I'm going to deny ever receiving this one, and they're not going to be able to do it. And actually, they'll probably give you your money back, right, if you do it once. But if you do it twice, 3 times, 5 times, then they're going to send the police to investigate. So that's just sort of built in. There's a certain level of fraud that's built into their models. But anyways, that's an example of repudiation. Information disclosure is just basically stealing things that are supposed to be secret. So it could be data, it could be personal information, it could be like credentials, like password theft, key theft, cookies, session IDs, hijacking, that type of stuff. So this, we'll spend lots and lots of time on all of these things: passwords, keys, cookies, and session IDs across this course. Privacy generally falls under information disclosure. I guess I was going to add some more things, but I forgot to. Denial of service is you prevent someone from being able to access a system. So most of the time you probably think of network, like DOS is like you take down a website that you don't like. So that is absolutely denial of service. I'll give you an example of that in a second. But there's more to denial of service than that. You could attack a process on a computer, get it to run out of memory, force it to reboot. Maybe you're in sort of a cloud environment and there's other people that are running beside you. And so you just want to like mess with them. So you force the computer to reboot. It reboots everyone, not just you, that type of thing. You could force data to be deleted so that people don't have access to it. So like there's this attack called SQL injection, and like the famous, like you can see cartoons and stuff like XKCD or whatever that cartoon is with it. But like the one is about like dropping tables, right, in SQL. Like I named my kid like drop table or whatever. And so but the idea of the outcome of that command, should you run it on SQL databases, it just deletes everything. So anyway, that's another type of denial of service. You can lock people out of accounts. So like say I don't want you to access Instagram, I'll just guess your password wrong 10 times and then it will put a 24-hour lock on it. It probably doesn't do that now. It probably does some sort of password reset through email. But anyways, that may or may not work depending on how the system is set up. You have an exam you didn't study. What do? You pull the fire alarm an hour before it or half an hour before it, right? And now the exam gets canceled. Or you call in and say there's a bomb. So there will be a story about that somewhere in this course, okay? And I'll tell you why that person got caught even though they used the anonymity software Tor. So you can wait for that. Okay, denial of service. I thought this might be fun just to drop into some level of detail. Okay, how does denial of service work in the network setting? So in the network setting, what we do is we have a website. Websites have an IP address. And what I want to do is basically direct so much traffic at that IP address that the computer that's handling it just can't keep up. Okay. Then other people, legitimate people, are trying to access it too. Their traffic's getting mixed into my traffic. Okay. But the server has to at least look at my traffic before it can throw it away. Right? It doesn't know which traffic comes from where, which are legitimate users, which are illegitimate. So it has to at least go through it at least a shallow enough level to at least decide whether to throw it away or not. Okay, so that's classically how you would bring down a website. Okay, what's a better attack than this? Okay, so DDoS. What is that?
Using zombie bots.
Using a botnet army to attack.
Okay. So very simply, so it's distributed denial of service. And very simply, what I'm going to do is instead of getting just me attacking the website, I'm going to get a bunch of friends to do it too. Okay? So how do I do that? So there could be literal friends, but you can also rent computers. Okay? So you can go into dark markets and you can rent a computer for an hour. Okay? Not a computer, sorry. You can rent 10,000 computers for 1 hour or whatever. How come you can rent those computers? Whose computers are those that you're renting?
Someone else's,
Someone.
not ours.
Yeah. So it's not yours, but like where are those computers, or like, why are they for sale?
Probably the victim of some other attacks.
Okay, yeah. So usually they're malware-infected computers. So it's literally like someone's computer, like someone in this class, and they don't know that they have malware on it, and somebody's renting out their computer for that hour, and they're using that computer to do the attack, kind of thing. Okay, so it's not just someone setting up 1,000 computers and renting them; it's actual victims, and that's important because they're all over the world. They look like normal users because they are normal users. Yeah.
So how does one help? So for example, if I use a certain website or an application,
Yeah.
an app, and the app sometimes it hangs, right? So and because a lot of people are using the website at the same time or app at the same time, that is also considered as DDoS or something?
Yeah. So it's a kind of accidental denial of service. Yeah, so it is denial of service. Is it an attack? Not necessarily an attack,
Yeah,
right?
exactly.
Like think of a voting system and everyone's voting at the last minute or something like that. They go down. We do call it denial of service,
Yes.
but we don't call it an attack.
Attack,
Yeah,
right.
yeah, that's a distinction. Yeah. Okay, so this is distributed denial of service. So this used to be like the best way to do denial of service. Now there's an even better way. Does anyone happen to know what it is? Okay, so I'll show it to you. I'll try and explain it to you before showing you the details of it. Okay, so forget about denial of service for a second. Okay, this is how there's a bunch of things on the internet that work. Let's say I go to a server and I just say, I don't know, well, I just say hello. It says hi back. Okay, so that's fine. Now, think a little bit about the length of the thing that I sent to the server. I said hello. It said hello back. They're the same length, right? Okay. Now, sometimes when you ask servers, you could ask, what time is it? And it would tell you the time. Again, it's probably about the same size. Okay. But you could say, oh, give me like the cryptographic certificates for like your identity and all the certificate authorities you use and things like that. You don't know what all those words mean. You will know them in a couple of weeks, but hopefully you're imagining it's a lot of data coming back. Okay, so it's a simple request like give me your certificate, and that's like a couple bytes long, and then you get back kilobytes of data. Okay. All right, so we have a short request and we have a long response. Okay, another thing that you can do on the internet sometimes, we'll talk about when and where, is you can actually lie about where the packet comes from. Okay, so if I go to a server and say I'm you, and I use your IP address on the from field, it will get routed from my computer, but when the server receives it, it doesn't know the route that it took. It doesn't know who actually sent it. It just looks at it and says, okay, this person wants me to send back index.html, like the root website, okay? And it's going to send it to the IP address that's in the from address, okay? So you can just totally make that up, and then you send it to the server, then when the server responds, it's going to respond to someone different than the person that sent it, okay? So we call that IP spoofing. So it's very simply, you send a packet requesting some information, and you just change who sent it. You write a different IP address in, and now it's going to redirect it to somewhere else. So for example, I send this request, this short request to this server, and I say, oh, this request is coming from this IP address, but this IP address is actually Concordia. Then the response from the server is going to go to Concordia instead. Okay? Now, let's say that the request is short and the response is long, right? What I did is I actually took my data, like the data that I was sending, and I was able to expand it or like kind of blow it up. And it's not me that's doing that work, it's the server in the middle. The server in the middle is doing the work for me. Okay? So what I can do is I can say, here's this, I set up this like spoofed IP packet, and I just say, give me that file, 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 as fast as I possibly can, okay? And those are like really short requests, so I can do it really, really fast. Then the server is going to start sending, here's the file, here's the file, here's the file, but this is a much bigger request, okay? So what I've done is I've kind of like taken my bandwidth, right, and I've multiplied it by 10 because the response is 10 times as big as the request. And so the traffic that's hitting Concordia is now 10 times bigger than it was coming out of my computer. So the traffic between me and the server and between the server and Concordia, it's 10 times bigger over here. Okay? So we call that amplification. I'm able to amplify it. Yeah, question?
I was just going to ask you the start with the amplification.
Yeah, exactly. Okay, so we call this amplification. Okay? Now there's one big problem with it. Okay? The big problem is that it basically never works. All right? Why does it never work? The answer is that when you send a request, before you can request anything of any size, you have to do what's called a handshake. So when you go to a website, you say hi, the server says hi back, then you say give me the file. Yeah, an acknowledgement, and then you say give me the file. Okay. The problem is that the handshake breaks down because you spoof the IP address. So you'll say hello to the server will say hello to Concordia, and Concordia will say, why are you saying hi to me? I never said hi to you. And then it will just drop it. Okay? And the hello that you send to the server and the hello back that the server sends, they're basically the same size. Okay? You can do that type of denial of service just to sort of hide the IP address where it's coming from. Okay? So that is possible, but you're not getting any actual amplification. Okay? All right. Now, that said, yeah.
So is it like kind of pre-flight call?
Yeah. Yeah.
That's the same thing?
It's not the same thing, but it's the same conceptual idea of like you do something first before you get to the protocol itself. Yeah.
So the solution for this attack is basically the three-way handshake that we talked about.
Yep. So the three-way handshake breaks this attack.
Exactly.
Okay. Now, is the three-way handshake always used? Can anyone give an example where it's not used?
Translating file, some certain kind of files.
Okay, so some certain kind of files, maybe not true. Someone else said UDP. That's the answer I was looking for. So the three-way handshake is part of a network protocol called TCP. Okay, and it also has error correction. It has a bunch of stuff in it. Okay, and most of the web runs on error correction and TCP. Because when you go to a website, you don't want to get half of the website back. You want to know that you got all of it. And say you're missing like packets in the middle, you know that you're missing them. So then you can ask the server, I'm missing 47 out of 100, give it to me. And then you can always reconstruct on your client exactly what you're supposed to see. Okay? So that's what TCP gives you. Okay? But sometimes you don't care that much. You care more about speed. So the problem with TCP is it adds error correction. It has this three-way handshake. Everything's a little slower with TCP. Sometimes you just want pure speed, okay? So UDP is the pure speed protocol. It does nothing, okay? There's no error correction. There's no handshake. There's nothing on top of it. It's just purely about speed. When do you want that? Well, let's say you're watching a Netflix movie on Netflix or YouTube or something like that. If packets get lost, right, by the time you ask them to send them again, you've already moved past that point in the video, right? So you don't care, they come too late, okay? So you get as much of it as you can, and maybe the video skips a bit or it gets a little blurry or something like that, and then as you get the packets, then the resolution improves, but you just sort of move on with it, okay? So it's just a best effort delivery mechanism where you try your best, and that's what it works, okay? So are there any UDP servers that you could give short requests to and get a long request from? And so the answer is that there actually are a bunch, okay? The one that started this whole amplification attack, they've changed how it works now. But there were these servers that are called NTP servers. Actually, NTP is a service that's on a server, okay? So almost every server out of the box, especially if it's running Apache Linux, it's going to support this protocol called NTP. And I mean, any server on the internet, like Google servers, Bell's servers, whoever your ISP is, Concordia servers, whatever. And some of these are big servers. They handle lots and lots of traffic, okay? And so someone thought it would be a great idea that you could just go to any of these servers and say, what time is it? And it would tell you what time it is, okay? Then you could synchronize your clocks and things like that, okay? So that was the idea behind NTP, or Network Time Protocol, okay? But NTP allows other things as well. So one thing that like basically nobody ever used, but it was always kind of there in the software, was you could go to an NTP server and say, give me the last 50 people who connected to you and ask you what time it is. And then it would say, okay, here's a whole bunch of IP addresses of all the people that asked me what time it is, okay? It's not the most useful thing, okay? But the one thing it is it's a response that's a lot bigger than the request, which is like, give me the list. Like this is sort of the size roughly of what your request looks like. And this is roughly the size of the response. And that thing's like 10 times bigger than the request, okay? And NTP servers can handle a lot of bandwidth, okay? So if you can hit these servers as hard as you can with all the traffic that you have, right? And say, give me the list, give me the list, give me the list, give me the list. It can probably keep up with, here's the list, here's the list, here's the list, sending that off to the spoof domain, okay? Because this thing runs over UDP, it doesn't run over TCP. Then there's other things too, like DNS runs over UDP. DNSSEC is even worse because you have these certificates and they tend to be big. And basically people sort of patch them so they'll go turn this off on NTP servers. So now either they just turn off NTP completely or they don't let you ask for this anymore. But then attackers like try and find what are some other UDP services where we can do amplification. And so we're in this sort of cat and mouse game of they find new things, they get turned off. They find new things, they get turned off. So anyways, that's an example of it. And this is what we'll see in the course, is a lot of sort of explanations like this of trying to like understand security properties or attacks and sort of tracing through a story about like why they happen and what they are. So this is the kind of thing that you can expect. Okay, the final category back to Stride is escalation or elevation of privilege. And so this is where basically privilege means like what you're authorized to do. If you escalate it, it means you do things that you're not authorized to do. It's beyond your authorizations. Okay, so it could be that you're sending inputs into code. It's not handling them properly. It could be that you gain access, like say write access when you should only have read access to memory. Maybe it's a system like say Windows where you're running in like a limited mode, you're not running as a super user, but the malware is able to break out of that and get super user privileges. Now it can modify your kernel and things like that. In general, like in security, we have a lot of sort of sandboxes or containers like, oh, that's running in an iframe, it's JavaScript. Because it's in an iframe, it's not allowed to do X, Y, and Z. It's not allowed to talk to things outside of the iframe. Okay, that's like a browser thing. Or it's a website, it's running in a browser. It shouldn't be able to leap out of the browser and infect your computer. Even if the website is bad, right, you shouldn't be able to mess up your computer visiting a bad website, right? Like it should all stay within it might do lots of damage to the website itself, but it's not going to do any damage to your browser or to the operating system because it's contained, right? Or I'm running software in a virtual environment or a Docker container or something like that. And so it shouldn't be able to break out of it. Or I'm running on a cloud and there's other people who are running beside me. I'm scared that they're going to break out of their containers and see what I'm doing, right? I don't want to be co-located with my competitors. What if they somehow figure out a way to see what the computations I'm running because we're on the same physical computer that's given to us by our cloud providers? Right. So the escalation of privilege is the end goal of a lot of attacks. It's usually one of the components of most modern day attacks. Okay. Questions about any of these? This was just sort of a whirlwind tour of the 6 categories of Stride.
In the escalation of privilege, can we talk about, because we talked about the Docker and everything, can we talk about databases as well
Yep.
in this?
Yeah. Sure.
Because there is something called a stored disk access system. There also access control where the escalation of privilege happened, can that be linked with this, or there are two different topics?
No. Anytime you have access control and you're able to break the access control, it's escalation of privilege.
Okay, that is what I was wondering.
Okay. So one question that will be on the final exam will be XYZ happens, is that STIRDE, whatever, right? And so that's one thing you can expect, okay? So I'll tell you that right up front. So now you know a couple exam questions. So you should be able to look at something and label it as, oh, that's a spoofing attack, that's a tampering attack, that's an information disclosure attack.
Sure.
Yeah.
Is Stride the usual go-to for usual threat models?
So it probably is. It wasn't historically. So Stride is like in the history of threat modeling, it's sort of new. It's kind of old now. Like maybe it's 10, 15 years old, but still it's not like CIA people were talking about, I think in the 80s or 90s kind of thing. So it might not be the go-to for everyone. I just included it because it's pretty widely regarded, whether it's the go-to or not. And this book has more than Stride in it. Like it has a bunch of different methodologies, and we're going to talk about some of those, like attack trees are also covered in this. But anyway, Stride is sort of the heart of it. And then Microsoft was the main pusher of Stride as well. So it's sort of a branded technology as opposed to like a neutral academic one. So for those reasons, it might not be considered the go-to, but it is prominent. Okay. Last thing I'll say is, so Stride and all these high-level things. Now that you know what it is, so someone hands you X, and you're like, it at least gives you a starting point. You can be like, well, are there spoofing attacks? What are all the ways that I could attack, like using spoofing? What are all the ways I could attack this using tampering? And it at least forces you to consider all the different things. Okay. Now, are you going to find some like break in the cryptographic math of an algorithm because you said maybe there's a non-repudiation attack? Probably not, okay? So it doesn't let you go deep. It doesn't tell you how to go deep, okay? All it does is it just tries to get you to think beyond maybe the box that you're thinking of. Like a lot of people think of tampering, right? So you get software, you're like, okay, what are the tampering attacks? But then this forces you to think about like, oh, maybe there's spoofing, maybe there's time of use versus time of check, that type of stuff. Okay, so that's what Stride's good for, but it's not going to turn you into like a security ninja overnight. Yeah.
Can we say Stride is the first step to the next one?
Yeah.
The next.
Exactly. Yeah. So it's a good first step. So on day one, someone hands it to you. You can brainstorm. You want to brainstorm like what security means and what the attacks are. This is a great step to just try and make sure that you're covering all the different things. Yeah. And then the other thing I mentioned too is if you want to present your results back, it's also useful too. So you could organize it. You could say, okay, let's talk about spoofing for a minute. Now let's talk about tampering. And it's a nice way to like sort of organize attacks in reports and projects and things like that. Okay, other questions?
Excuse me, doctor.
Yeah.
During the lecture, you only discuss about threats, not solutions.
Yeah, true. Yeah, so the solutions let me just sort of quickly go through. Okay, so the solutions are kind of, first off, the umbrella category would be here, right? So to prevent to prevent spoofing, it would be in the class of authentication. So authentication, it's going to look very different for, are you authenticating a process? Are you authenticating code? Are you authenticating a human? So for a human, it might be a password, a biometric. For like software, it could be like a certificate that's signed. So these would be ways of addressing spoofing, but basically you need an assertion of the identity of it from a trusted source. It's more or less what most things boil down to. For integrity, it's all over the place, right? So like to prevent tampering with hardware, it could be some physical thing. To prevent you from getting into this room when it's locked, again, it's a physical thing. To prevent you from modifying the software, well, I have to look at all the software vulnerabilities that I know about and sort of go through and make sure. And there's going to be tools that allow me to automate that, like static analysis, dynamic analysis, and things like that. You could do like higher level things like I want to lock down the control flow of software. So when software starts jumping around, I want to say, okay, if you're jumping into the function here, these are the only places that you can jump in from. You can't jump in from anywhere else. So I'll add a bunch of infrastructure to the code to enforce that. So that's called control flow integrity. But anyways, that's like a very specific example. Non-repudiation is a little easier. Logging things is mainly how you deal with it. Confidentiality, things like encryption or anonymity are the main two things that are used. Availability, you can't really solve. A lot of it just comes down to like, I have more bandwidth than you, or I have a faster computer than you, or whatever. I have more resources at my hand than you have. And then escalation of privilege, it's about setting a policy, and it's two parts. One is enforcing the policy. So that might be with software, or might be different ways. And the second way would be to make sure that the policy doesn't have loopholes. And that's actually a lot harder to do. And there's no good methodology for doing that. So of all the things I just went through very, very quickly, we'll spend a bit of time on spoofing next class when we talk about passwords. We'll spend a lot of time on escalation of privilege. We'll have a bunch of things on policies. We'll also talk about spoofing in the human context. So we'll talk about social engineering. And the other ones we're going to see, information disclosure, we'll talk about something called SSL, which is a network protocol that gives you confidentiality. And we'll talk about how to break it for 3 lectures. So you'll see lots of different things that SSL does to protect itself, and then things it does also, different attacks that you can do. And it turns out that SSL also relies heavily on authentication. So basically it doesn't work. You can't get confidentiality unless if you have authentication. And so these things are all going to get tied together. But anyways, the point is that like this won't be the last time. It's the last time I'll show you Stride as a methodology, but the whole course we're going to be like, oh, that's spoofing, that's tampering, that's information disclosure. You're going to see like 20 examples of each of these things by the end of the class. Yeah. Other questions? Okay, so seeing none, that's all I had, I think. Yeah. Okay, great. So I'll see you all next week. Yeah. No worries.